Okay, for this problem, right? We have IA 5 amp, IB 10, IB 10 amp, R1 2 ohm, R2 5 ohm, R3 2 ohm, and R4 10 ohm. Okay, so how much for I R4, the current flow here? Okay. So we can find this current by V2 divided by R4. We construct the equation to solve for V1 and V2. So for the first equation with node number 1, we take KCL. So 5 amp flowing into the node. So if we denote the current flow into the node as positive, flowing out will be negative, and flowing out will be negative, right? Okay, so flowing in is 5 amp. And how much for the current flow out? Yeah, it's V1 is minus V1 divided by 2 ohm, right? And then how much for this current is minus V1 minus V2 divided by 5 ohm, right? This is the sum of current is 0. Right? So we can rearrange this equation to be multiplied by 10, right? To this equation, then we get 50 amp minus 5V1 minus 2V1 minus then plus 2V2 equal to 0. We rearrange this equation, then we get 7V1 minus 2V2 equal to, this is minus, then plus and minus, then 50, right? This is equation 1. Then we take node number 2 by KCL. The current flowing in is 10 amp, right? Plus 10 amp. This is minus, and this is minus, right? And this is minus. 10 amp minus this current V2 by 2 ohm minus this current V2 by 10 ohm, and then this current minus V2 minus V1 divided by 5 equal to 0. We rearrange this equation, so we multiply by 10 into this equation, then we get 100 minus, multiply by 10 is 5V2, multiply by 10 minus V2, multiply by 10 is minus 2V2 minus and minus, then plus 2V1 equal to 0. Then we rearrange this equation. Sorry, this is V2, right? V2. Yeah. 2V1, 2V1, 2V1 minus over here 5 5V2, 1V2, and 2V2, then 8V2, right? 8V2, 100. Come to this side is minus 100. This is equation 2. We solve equation 1 and 2, right? We get the answer, right? For V2, if I out V2, then we can get current here, right? Okay. How much for V2? So in fact, this equation is V1 minus 4V2 equal to minus 50, right? Minus 50. equation 2. So to find out we multiply 7 to this equation, so 7v1 minus 7 into 4, 28 v2, 7 into minus 3 fifth. This is equation 2, right? So with this equation and this equation we subtract. It's equation 1 and 2, right? 1 and 2. Equation 1 subtract equation 2, right? One minus 2. 1 minus 2, we get 26 v2. 1 minus 2 equal to 300, right? So v2 is 300 by 26. How much for v2? R4 is v2 divided by R4 is 300 by 26 by 10 is 300 divided by 260. So how much for this? How much for this? Am I right? Any mistake? So let's check it. Here the same answer. Oh, 50. Okay, 400. Correct. 400 here. 50 plus 250, right? 350. Okay. 350 is 400 here. So the step is quite systematic, quite standard, right? First, you try to solve for voltage first. If you want to get the current, so later, after you get the voltage, you can get all current, right? In any branch, you can get all current in any branch. So first, try to get the voltage. After that, you solve for other parameter. Okay. Yeah. This is a nodal analysis, right? Okay, this is nodal analysis. So please try to check whether any mistake here or not. Also, right? Okay, next we come to another method to solve the circuit. Okay, so this method we use KVL to solve the circuit. Okay, by define the mesh current. Okay, we start with define the mesh, and then we solve for the mesh current first. In this case, we will get the current as a solution. Our equation will form in the notation of current, okay, and in the form of current. For example, if we have this type of circuit, so we define two meshes, right? In this in the left hand side mesh I1, we don't know I1, but in the right hand side, in this case, we know IS. IS is a known. So IS will flow in this case, right? So usually when we define the mesh current, we will define positive direction by clockwise direction. Okay, this direction will be positive current. So if we solve the current and we get its negative value, so for example, if we solve for the mesh current and we get the negative value, it means that it's in the opposite, it flow in the opposite direction. Okay. Similar to the node voltage, if we solve and we get the negative value of our solution, it means the direction of the voltage is opposite. Okay, just like that. Okay. With current source? No. Sorry. Yeah. Okay. Sorry. First, we need to talk about the mesh without current source, right? Here, the node current analysis method by KVL. Okay. So first, if we consider the circuit without any current source, okay, so we can define the mesh of the system by clockwise direction as a positive direction, okay, in this case. And in a circuit with N mesh and M current source, in this case, if we have M current source, that source we know the value, so our equation remain only N minus M. Okay, equation. Okay, yeah. And then we solve for the linear system. We will get the linear equation set for N minus M unknown. Right? We solve for I. We will have unknown N minus M value. So if we have M current source here, just like this. For example, if we have this circuit, in this case, we will have three meshes, I1, I2, I3. So we construct three equations and three unknown. But if we have some current source, for example, if we have this current source, IS, so we know that then I3 equal to IS. So our equation remain only two equations and solve for two unknown. Okay, so we solve for N minus M. If we have M current source in the system, so we know that current, right? We don't need to solve for the mesh. So, okay. Okay, let's see some example, right? Here we have two mesh, but without any current source. Okay, for without any current source, so we will have two mesh. So we will solve two equations, two unknown. So in this case, we define I1 and I2 as a mesh current. Here, I1, I2 as a mesh current. So the direction is clockwise direction. Okay. So then we take KVL. Okay. Let's see KVL for mesh number one. Mesh number one. This is positive value, right? Positive, negative. So plus V1 here, plus V1 and minus minus I1 into R1, right? Minus I1 into R1 is small v1 here. Minus R1 into R1, right? I1 and R1. This is the voltage, right? And minus. How much for this voltage? It's V2, but it's negative value, right? Coming out from negative. Okay. And how much for this voltage? V2. V2 will be, in this case, we consider this direction, right, as a positive. So it will be minus here, right? Here. How much for the current? The current flowing through R2 is I1 minus I2, right? I1 minus I2 here. This current is I1 minus I2, right? This is I2. So this is I1 minus I2, right? The net current to R1. Okay? But at this moment we don't know what is I1, what is I2, right? We find out how much for the mesh current. So we get this equation. This is the first equation. Okay. Then see for the second loop. The second loop here is R2. If I take it systematic, if we consider this is the correct direction, this is a positive direction, so the current will flow plus minus here I2. The voltage across R2 will be negative V2, right? It's minus. If I take the minus sign, the voltage across R2 would be minus R2 into, so this is the positive direction, right? So now we get I2 minus I1, sorry, I1. I2 minus I1. Then how much for V2? Plus V2, right? Plus V2. Plus V2, and then this is plus minus, right? So it's minus R3 I2, and then minus V3, and then minus R4 I2 equal to 0. This is the same equation, right? So the last four terms are same. And the first term we just change it positive to negative, right? I1 and I2. This same equation. So just keep systematic, right? I2, this is positive direction. In positive direction, this is plus minus, minus, right? Because last time I already said the current will flow out from the source, flow out from positive polarity, right? But flow to the load, when the current flow to the load, it flow into the positive polarity, right? Source and load is different defined, okay? And then you just keep systematic to do. Otherwise, you get some confusing in the positive, negative side, okay? And you construct the wrong equation. If your equation is wrong, your solution will be wrong, right? Okay. Then we substitute V1, V2, V3, R1, R2, R3, R4, and rearrange, we will get this equation. Okay. For example, for the first equation, V1 10 minus R1 5 into I1 minus V2 is 9, and then minus R2 10, right, into I1 minus I2 equal to 0. So how much for this? 10 and 9. 10 and 9 is 1. 1, 5 minus 10 minus 15 I1 and 10 and plus 10, right? Plus 10 I2 equal to 0. So we move this to another side, is 15 I1 plus 10 I2 equal to 1. Then we get this equation, right? Just substitute, then we get this equation. Similar for the second one. Then we solve for I1 and I2. We get I1 0.5, I2 0.65. 0.5 and 0.65. So the current I1 is 0.5 plus 2 R1 and 0.65 plus 2 R3 and R4, right? In this direction, because we get the positive value. It means that the direction is clockwise, right? How much for the current flow through R2? R2 it should be I1 minus I2, right? The current flow past R2 will be I flow to R2. If we divide, R2 will be I1 minus I2. It is 0.5 minus 0.65 equal to how much? Minus 0.15 amp, right? So this current is minus 0.15 amp. It means that in fact it's flowing up 0.15 amp, right? Because we get the negative value for this direction. In fact, it's flowing up 0.15 amp. Yeah. So we can also solve the circuit by mesh analysis. It's a second method. Okay. So if we have voltage source in the circuit, it will be easier to construct KVL, right? Because we know the voltage, right? By mesh analysis. But if we have a lot of current source, for example, this example, it's easier to construct node analysis because we know the current, right? We know this current, right? But we don't know how much the voltage across, right? But we know the current, so we can substitute current directly here, right? Here. Okay. Okay. Now let's see this example. Okay. This example we will have three mesh. Okay. So in this circuit, we know V1, V2, R1, R2, R3, R4. V1 is 12 volt, V2 6 volt, R1 3 ohm, R2 is 8 ohm, R3 is 6 ohm, R4 4 ohm. Right. And we define the mesh. Keep the mesh clockwise. clockwise is positive. Okay, so let's see mesh number 1. Mesh number 1. It should be positive, negative, and positive, negative. This is the positive direction, right? So in this positive direction, we get positive, negative, and negative, right here. The current flowing out from positive, flowing out from negative, flowing out from negative polarity. Then first equation will be 12, right? Plus 12 minus how much for this voltage? It should be 3 ohm into I1 minus I3, right? I1 minus I3, right? It's I1 minus I3. How much for this current? Is negative, this voltage, negative 8 into I1 minus I2, right? This is the first equation. This is our first equation. So we can rearrange this equation, right? We rearrange this equation. And then we get minus 3I1 plus 3I3 minus 8I1 plus 8I2 equal to 0. 3 and 8. 3 and 8. Yes. 3 and 8. 11. 11I1. 3 and 8 also, right? No, only 8, right? But I change the size. Minus 8I2 minus 3I3 equal to 12. I change to this side. Okay, this is should be equation 1, right? Check it. Okay. Similarly, we can solve for mesh 2. How much mesh 2? In this case, if I keep the direction of I2 as reference, so it should be plus minus here, plus minus here, right? And this is plus. Then this is plus 6 volt minus this voltage minus this voltage. Okay. Then our second equation will be plus 6 volt minus 8 into now I2 minus I1. I2 minus I1. Here 6 minus 6. I2 minus I3, right? I3 will be this direction. I3. I2 minus I3 equal to 0. Just rearrange this. We get minus 8I1, right? 8I1 minus 6. Okay, step by step. 6 minus 8I2 plus 8I1 minus 6I2 plus 6I3 equal to 0, right? So we move to another side. It's minus 8i1 plus 14i2 minus 6i3 equal to 6, right? This is the second equation. Okay, this second equation. Now, third equation.
I think the top one is now is minus. It is supposed to be plus 8i1 minus 40i2 minus 6i3.
Plus,
Yeah.
minus,
Yeah.
plus, then this will be minus. The same equation. Okay, otherwise it's minus. The same equation, right? Okay. Then, maze number 3. Maze number 3. Then we keep the direction of I3 as the positive direction, right? So this is plus, minus, plus, minus, plus, minus, right? So negative, right? Negative t into how much? Minus 3 into I3 minus I1, right? I3 minus I1, and then minus 4 into I3, right? And then minus 6 I3 minus I2 equal to 0. Then minus 3I3 plus 3I1 minus 4I3 minus 6I3 plus 6I2 equal to 0. Then how about I1? I1 is 3I1. 3I1 plus 6I2. I3 minus 3 minus 4 minus 6, then minus 13I3 equal to 0. So this is equation 3, right? Equation 3. So now we got equation 1, equation 2 and equation 3. Okay, the next task will be solve 3 equations, 3 unknown, right? If we solve 3 equations, 3 unknown, we will get I1, I2, I3 in the mesh. Okay? And how much the current flow to R2? We just get I1 minus I2, you know, the current flow across R2. How much the current across R1? This would be I1 minus I3, right? We get the current across R1. Okay, it's depending on we define which direction. If we get the negative value, is mean the opposite direction from our denote at the first, right? We just solve this equation. So this is the same equation. This is the final set of equation to solve, right? Same one, right? Just put negative into equation 3, we get this. Okay, this is the equation. Okay. So I think you can solve by yourself, right? For 3 equations, 3 unknown, right? No. 3 equations, 3 unknown, right? Just solve and check the answer by substitute answer, right, into the equation, whether it's correct or not, right? Okay. So the important thing is practice also. You know how to solve, but if you do not practice much, you get a trouble in doing exam. Okay? Right? Practicing is important for doing the calculation, okay? Problem. Solving circuit, you need to practice a lot of problem. Maybe you solve 10 questions, 20 questions, you find out the problem from any textbook to solve it, okay? And you keep systematic for node analysis and mesh analysis, okay? Okay, I think I will make something. Yes? Can, yeah, sure. You can take calculator in exam. Yes. Okay. Okay. You can use any calculator. Okay. No, cannot use the communication device, right? Only the calculator. Okay. Okay, so you need some break for 5 minutes. Okay, take 5 minutes and come back.